Okay, so yesterday, last point we stopped at the discussion of exercise 9.3, question number 25. Pujita asked to explain that question. If A, B, C, D are in GP, show that A square plus B square plus C square multiplied by B square plus C square plus D square. B square plus C square plus D square is equal to AB plus BC plus CD complete square. Okay, this is the required result. So let's start. How to start thinking over this question is, we are yet to touch the topic of means, arithmetic means and geometric means. So that part we will see today. What is the meaning of arithmetic means and geometric means? Okay, arithmetic means and geometric means, and slight introduction of harmonic progression also we will see, not details but only a slight introduction. So and then we'll see the topic of means. So here there is when three numbers are in geometric progression, let's say PQR, let's say if they are in GP, then we say that this Q is the geometric mean of P and R. So PQR in geometric progression, what result do we have? Q upon P is equal to R upon Q, the definition of a geometric progression. Q upon previous term is equals to R upon previous term. So ultimately what result we have? Q square is equals to P multiplied by R. So whenever you see a result of this format, square of a number is equals to product of other two numbers, we can immediately say that whatever that number is squared is the middle number. Middle number means it's they form a geometric progression. Write Q in between and write P and R first and third. Okay, so here the question that he has shown, we can think of it as, so this is the square of that number, square expression, R right hand side. Right hand side square is equals to product of two brackets. So we can say that this right hand side bracket is the middle geometric mean of the first and the third in this bracket. Okay. So to prove means, what I'm trying to say is, to prove bracket 1 multiplied by bracket 2 is equal to bracket 3 complete square is same as proving bracket 3 upon bracket 2 is equal to bracket 1 upon bracket 3. Do you agree with me? The original expression what he is trying to prove, bracket 1 into bracket 2 is equals to bracket 3 square. Here square is there, bracket 3 square. So ultimately bracket 3 square means what? What do we have to prove? Bracket 3 into bracket 3 two times. This second term I have brought here, and here the one of the P3 I have brought on the LHS. Reverse order I'm trying. Reverse order I'm approaching. Is this clear? If I prove this, my proof will be completed.
Yes, sir.
Okay. So now let's find out what will be bracket 1, bracket 2, bracket 3 in terms of first term and the common ratio. So the first term, that's a B, C, D. Okay. So A, B, C, D, what do we have here? A, B, C, D. This, let it be A only. B is equals to AR, C will be AR square, and D will be AR cube. Okay. Now a square plus b square plus c square, a square plus b square plus c square, which is my bracket 1. This turns out to be equal to how much? This turns out to be equal to, sir, a square. What is b square? So b square is a square r square and c square is a square r to the power 4. Can I write in one step? 1 a square common, 1 plus r square plus r to the power 4. Will it be okay? Answer, students. Pujita, Dhananjay, Afreen. Is this step clear?
Yes, sir.
Pujita, no response from your side. Let me see. A square I have written as it is. What is b square? So b square is a square r square. Yes or no? What is c square? So c square. Here is my c. A into r square. Its complete square. A into r square. Its complete square means what it will be? A square r to the power 4. Correct? So I will take now a square as common. What remains in the bracket is 1 plus r square plus r to the power 4. Now is it okay? Second bracket b2 is what's b square plus c square plus d square. So b square is what? B square is a square r square. C square is a square r to the power 4 and d square is a square r to the power 6. Now among these three terms I will bring a square r square as common. So if I bring a square r square as common, the here 1 remains. Then here r square will remain and here r raised to 4 will remain. So 1 plus r square plus r to the power 4. And lastly ab plus bc plus cd. ab plus bc plus cd. This is my bracket 3. So what is AB? AB is a square r. What is BC? BC is a square r cube. And what is CD? CD is my a square r to the power 5. So a square r as common. What remains in the bracket is again 1 plus r square plus r to the power 4. Now can you see here? Now only concentrate on this much, b1, b2, b3 and this part. So what is b2 upon b1? Yes, this is a square, a square, a square everywhere. It is a square is present everywhere. Here is r square, here is r, and here nothing. So b2 upon b3. b2 upon b3. Can you see that here, sir? b2 upon b3 here it will be, sir, r square present is there, a square, and this 1 plus r square plus r raised to 4, it is present everywhere. b2 upon b3 will be equal to r. Can you see this thing? And sir, b3 upon b1, if I take b3 upon b1, b3 upon b1 will also be equal to r. b3 upon b1 will also be equal to r. That is what we wanted to prove. So ultimately, now do the cross multiplication. So b1 into b2, b1 into b2 will be equal to b3 complete square. Yes, b1 into b2 will be b3 complete square. Hence prove.
Yes, sir.
Okay. Background noise is coming from my side. Or is it okay? students? Is some background noise coming from my side?
Yes, sir.
That, that I won't be able to help because my now after this question, first let's study the concept of means, arithmetic means, geometric means. Little harmonic progression also, just the definition I will give you, and then we will study the concept of means. Okay, harmonic progression, just the definition parts. Let's finish it quickly. Harmonic progression. Now, harmonic progression is what, sir? AP and GP you have already seen. Harmonic progression is very close to arithmetic progression. Okay, so if H1, H2, H3, H4, so on and so on and so on, are said to be in harmonic progression if their reciprocals are in, what happened, Afreen?
Nothing.
If their reciprocals are in arithmetic progression. Okay, H1, H2, H3, H4, these terms are said to be in harmonic progression if their reciprocals should be in AP. That is, if 1 upon H1, 1 upon H2, 1 upon H3, so on and so on and so on, are in AP. So if I can tell you like example, zero 0.5, 0.25, 1 minute. 1 upon 2, 2 upon 5, 1 upon 3, 2 upon 7, 1 upon 4, 2 upon 9, dot. This sequence is in HP. How to check? To check whether this sequence is in HP or not, just consider the reciprocals. The reciprocals are set 2. The next reciprocal is 5 upon 2. 5 upon 2 is 2.5. Yes or no? The next reciprocal is 3. Next reciprocal is 7 upon 2. 7 upon 2 is 3.5. The next reciprocal is 4. The next reciprocal is 9 upon 2, 4.5. So on. This form an AP. So yes, just 1 second, students. Yes. So this sequence is an harmonic progression. Okay. So now arithmetic harmonic progression, I hope you got the definition. Now, if you got this definition of harmonic progression, as such, there is no formulas. There are no simple formulas for harmonic progressions. Okay, harmonic means now definition of harmonic means, let's say sir, H1, H2, H3, H1, H2, H3. This is an harmonic progression third term. So the middle term will be harmonic mean of first and third term. That terminology is given here also. As such, there are no simple formulas for harmonic progression. AP and GB, the formulas were very simple, so we derived them. Okay. So now means. Next topic we will come to arithmetic mean, geometric mean, and harmonic mean. Okay, arithmetic mean, geometric mean, and harmonic mean. So what is arithmetic mean, sir? Arithmetic means is the first case scenario. If A, B, C are in A, B, C, let them be in arithmetic progression, then B is called as arithmetic mean. So arithmetic mean AF, geometric mean GM, and harmonic mean HM. Then B is called as arithmetic mean of A and C. So two numbers are given, and if you want to find the arithmetic mean, what is the formula? Let us derive the formula. So A, B, C are in AP. So what result do we have? Difference of B and A is same as difference of C and B. B minus A equal to C minus B. Definition of AP only. So 2 times B is equals to C plus A. From this I can conclude that B is equals to A plus C upon 2. So this is the formula to find arithmetic mean of A and C. Two numbers are given. Find the arithmetic mean, you can find out. This is something similar to insert one number between two given numbers. Insert one number between fixed A and C so that all three of them are in it. Something like that only it was. Okay. Easy it was. Now the second part is geometric mean. For geometric mean, let's consider A, B, C. Let them be in geometric progression. Then B is called as geometric mean of A and C. What will be the formula for B? So by definition of GP only, we know that B upon A is same as C upon B. So can I write B is equal to A multiplied by C, its under root. Of course, the negative one will also be the geometric progression. The positive one will also be the geometric progression. Okay. Under root, if you take the negative value also, that also will be the geometric progression only, because negative means if I tell you it's find geometric mean of let's say 5 and 80. So the 5 and 80, the one term that you insert in between, it can be 20 also, or it can be negative 20 also. 5 into 4, 20, 20 into 4, 80. That way also this is a GP. 5 into negative 4 minus 20, and minus 20 into negative 4, 80. That way also it's a GP. So for now we will deal only with the positives. Okay. So this is the formula for geometric mean. Two numbers are given, their product under root is equals to the geometric mean. And third, This is geometric mean. This is arithmetic mean. And third, A, B, C are in HP. A, B, C are in HP. So, sir, what will be then? B is called harmonic mean of A and C. So, how to calculate B? Forget about HP. Whenever the question comes of HP, don't tell that I will memorize the formula of HP. Return to arithmetic progression. How will you return to arithmetic progression? We know that 1 upon A, 1 upon B, and 1 upon C, they are in AP. And since they are in AP, 1 upon B is equal to the middle term is equals to first term plus last term is completely divided by 2. So this complete upon 2 can I write over here? So how did you get this formula? This one. Middle term is equals to first plus last upon 2. First plus last upon 2, that upon 2 I have written over here. Got it? So just reshuffle this thing, and after reshuffling I will get B is equal to, if I solve the RHS on solving becomes A plus C upon AC. And then bringing it becomes twice AC upon A plus C. Okay. Is this part clear to everyone?
Yes, sir.
Okay. So this was actually we want for boards, definitely we will be dealing with 3 numbers only. 2 numbers are given, find the AP, GP and HP. That's it. So these 3 formulas you should know. If n terms are there, n general terms. So for n general terms, how to find the AP arithmetic mean, geometric mean and harmonic mean? So harmonic mean is calculated as, okay, so let us leave at that part. One generalized result. This result I will give you without proof. It's just a standard formula that if A1, A2, A3, A4, so on up to AN, Bn positive numbers, then arithmetic mean is equal to n positive numbers. When I'm saying no progression needed, no progression needed. It can be any n positive numbers. All of them should be positive. Any n positive number. So their arithmetic mean in general is defined to be equal to, sir, A1 plus A2 plus so on up to nth term. This complete divided by n. Something similar to average. A plus C upon 2, something similar to average only, A1, A2 plus AN up to n. For geometric mean, what we were doing, so geometric mean of, when B was geometric mean of A and C, we derived B equal to AC under root. So if A1, A2, A3, A and B, any n terms positive, their geometric mean in general is defined as, so take their products A1 into A2 into A3 into A4 up to AN, and their product complete nth root, not square root, nth root. For 2 terms, when we were taking the product, it was n. Here, if we were taking square root, here we are taking the nth. the complete product of n terms, it's nth root. And so how to calculate the harmonic mean? Harmonic mean, again, I don't want to memorize the formula. If I arrange the formula, it will become very complicated. So harmonic mean, what I will do, I will not calculate I will not write the formula for harmonic mean. I will write the formula for 1 upon harmonic mean. Okay. So sir, A1, A2, A3, A and B, n positive numbers. H is the harmonic mean. Okay. Means what, sir? 1 upon A1, 1 upon A2, 1 upon A3. Consider this as 1 upon An. These are not actually in AP, but the logic we are giving like that. Here now we are calculating arithmetic mean for any n positive numbers. Geometric mean for any n positive numbers. So H is harmonic mean of any n positive numbers. So we will use the same logic of AP. 1 upon A1, 1 upon A2, 1 upon A3, 1 upon AN. Considering them as AP, 1 upon H will be the will be the arithmetic mean. So 1 upon H will be what? So 1 upon H will be equal to 1 upon A1 plus 1 upon A2 plus 1 upon A3 up to 1 upon AN. This complete upon N. Do you get this?
Yes, sir.
Okay. So you can write here 1 upon harmonic mean is equal to 1 upon A1 plus 1 upon A2 plus 1 upon A3, so on up to 1 upon AN. This complete divided by N. Okay. In the books, it is given harmonic mean equal to. So harmonic mean equal to N upon this very ugly denominator. This denominator is very different. It's very complicated. N upon this very denominator, and so there we get scared. Why it is coming such? So you should have tell to yourself it is 1 upon HM is the arithmetic mean. Now, once you got these formulas with you, there is a standard result. For A1, A2 up to AN, if they are all positive, if A1, A2, A3 positive, then arithmetic mean is always greater than or equal to geometric mean, and geometric mean is always greater than or equal to harmonic mean. This is the result that we have. Provided the condition, they should be all positive. If arithmetic mean always greater than or equal to geometric mean, greater than or equal to harmonic mean. Equality occurs. Equality occurs if A1 is equal to A2 is equals to A3 is equals to A4 is equals to A5, so on, if it equals to AN. Okay, this is the result. The proof of this result, we will deal only with 3 numbers A, B, C. For general n numbers, the proof is out of syllabus, so that we will not deal here. This is one result, and another result also I will give you. Both the proof I will combinedly I will give you. For 2 numbers A and C, if A, G and H be the arithmetic mean, geometric mean, and harmonic mean of two numbers A and C, then G is then A, G, and H themselves are in GP, geometric progression. Okay. If A, G, and H are be the arithmetic mean, geometric mean, and harmonic mean of two numbers A and C, A, G, H themselves are in GP. That is, G square is equal to A multiplied by H. This is another result. Both these results proof we will see. Okay. Have you written them down?
No, sir, last one.
Write them.
Done, sir.
The proof of the second one, it's very easy. This G square equal to AH. This is just a clerical work. Means you can do it, nothing difficult. So we know all the three values. The first value is A plus C upon 2. The second value G is equals to AC under root, and the third value H is equals to what? So the third value H, I don't remember even. So 1 upon H will be equal to 1 upon A plus 1 upon C, this complete upon 2. Yes, so now I will calculate. So this turns out to be equal to twice AC upon A plus C. Means I'm telling you how to think in exams also. In exams, if you get stuck, how to think. Okay, 1 upon H equal to this. Got it? Sir, if you want to do this, what is our target? To prove A, G, H are in GP. G square equal to AH means we are trying to prove A, G, H are in GP. So what is the value of G upon A? G upon A turns out to be equal to AC under root upon A plus C upon 2. So what is H upon G? So H upon G is equals to, H is twice AC upon A plus C. This thing is divided by AC under root. So can I cancel this thing? Means this not exact cancellation. This AC is square of the denominator. So square of the denominator. So 1 under root I can cancel out. AC, the numerator AC, it is actually under root AC, 2 times. So I will just 1 under root will remain. Got it? So sir, G upon A is equal to H upon G. Now how you interpret this data? that sir A, G, H are in geometric progression. Two ways of writing. Either you say A, G, H are in GP, or you say G square equal to AH. That is one and the same thing. Done. The second proof is over.
Yes, sir.
Okay. Now the coming to the first part. Here, if A1, A2, AN are all positive, then AM greater than geometric mean is greater than or equal to harmonic mean. Two conditions are important. A1 to AN, everything should be positive. Now this proof, it's very complicated, but it's out of syllabus also. We will prove only for A1, A2, A3. So the two numbers are given, A1 and A2. Okay. So now second proof. To prove arithmetic mean greater than or equal to geometric mean greater than or equal to harmonic mean. Okay. Consider A and C. So what do we have here, sir? Arithmetic mean is equals to A plus C upon 2 and geometric mean is equals to AC under root. Okay. Just consider out of randomly that sir A minus G, how much it will be. I'm just considering what this value will be equal to. A minus G will be equal to how much? Let us see. So A minus G will be equal to A plus C upon 2 minus AC under root. So this will be equal to what? A plus C minus 2 times under root of AC, this complete divided by 2. So this will be equal to what? Now this is actually now subtraction 2 times under root A under root C. And A plus C is what? So root A is under root A square and C is under root C its square. So under root A square under root C square minus 2 times under root A under root C. So can you see now this is equals to root A minus root C whole square divided by 2, which will always be greater than or equal to 0. Equality will occur if A is equals to C. Done. So root A minus root C upon whole square upon 2 is always greater than or equal to 0. Therefore, A minus G is always greater than or equal to 0. That is, A is always greater than or equal to geometric progression. Similarly, you can prove for G and H also. G minus H if you do. This is your G and this is your H. Geometric progression minus H. There also you will get the result. Okay. Or you can also say that if another way of proving is now, sir, A is greater than or equal to G. For harmonic progression, I will use this result. Another shortcut method, sir, A upon G is greater than or equal to 1. However, there is a note of caution over here. What caution? Considering the G that we have inserted is positive. We are completely dealing with positives only. I have told you earlier also. We are dealing in positives only. Only then you can do this deviation and maintain the inequality sign. A upon G greater than or equal to 1. So, but what is A upon G? But A upon G is equals to G upon H. Therefore, G upon H is always greater than or equal to 1, since A upon G is greater than or equal to 1. So G upon H is always greater than or equal to 1 means what? This implies G is always greater than or equal to H. Combining all the previous results, result number 1 and result number 2, A is greater than or equal to G, greater than or equal to H, hence proof. Done.
Yes, sir.
Yes, sir.
Okay. So here the theory part of your this chapter is completed. Now only sums is left. Now we saw some sums. The theory of sequences and series is over. Harmonic means and also yes, one is complete. One part is left of arithmetico-geometric series, but that is not for boards. So that part we will deal on Saturday. There is a concept of combination of arithmetic and geometric series. All both of them combined in one. So that we can deal on Saturday also. Now let's do some questions. If in an arithmetic progression the sum of n terms is given by Sn is equals to five n square plus 2n find the nth term.
Sir, answer is 25n plus 3.
No, it's not 25n plus 3. It should be 10n minus 3. Okay, see, it's not that difficult sum. Nth term is asked over here. Okay, so when nth term is asked, so Sn is given. So Sn is what? Actually, here only one thing you need to know. Okay, Tn, just direct formula I will write. Tn. If you can think, conclude this result directly, then it's well and good. Nth term is sum up to n terms, sum up to n minus 1 terms, their difference. If this result clicks to you, then the sum is over. Why? Because Sn is T1 plus T2 plus T3 up to Tn, and S n minus 1 is addition up to n minus 1 terms. T1 plus T2 plus T3 addition up to the n minus 1th term. Here it's full stop. So when you do the subtraction, only the nth term will survive. Okay. So n, is this formula clear to you? Nth term is equals to sum of n minus sum of n minus 1. So what is sum of n terms? Sum of n terms is 5n square plus 2n. And note here the condition is, here there is an important condition, that is n should be greater than or equal to 2. Only then this formula is valid. For n greater than or equal to 2 only, this formula is valid. For n equal to 1, the formula fails. So 5n square plus 2n, subtraction Sn minus 1. Sn minus 1 will be what? 5 times n minus 1 square plus 2 times n minus 1. Okay, so it will be equal to 5 times n square minus n minus 1 square plus 2 times n minus n minus 1. So this will be equal to 5 times 2n minus 1 plus this will be equal to 2. So that turns out to be equal to 10n minus 3 for n greater than or equal to 2. The first term is independent. Okay. Okay, students.
Yes, sir.
Sir, one scroll down, sir.
Yes, sir. Scroll down, sir.
I purposefully wrote here 5n square minus n minus 1 square here, so that you can in future also, if you get a cubic equation also, means for quadratic for the summation of n terms, you will always and always get a quadratic equation only. But for other questions, not of AP, GP or something, but in any general question, if you want to do related to n, means sequence, means formula related to n, subtraction formula related to n minus 1. So this way you can do the coefficient outside n square minus n minus 1 square, coefficient outside n minus n minus 1. That's why I wrote this.
And sir.
if, okay, just evaluate two plus one plus 1 by 2 plus 1 by 4 plus 1 by 8 plus dot. Infinite terms. Are you able to do, students? You see, here only one thing is that you have realized that this is a geometric progression. Yes or no?
Yes, sir.
Geometric progression where the first term is 2 and the common ratio
Yes,
is
sir.
half. Whenever the magnitude of common ratio is less than 1, magnitude is less than 1, the series converges to finite. The addition of the series, it converges to a finite number. So, sir, Sn, sum of n terms is what? A times, now here I will use 1 minus r raised to n upon 1 minus r to avoid the negative denominator. So this will be something like 2 times 1 minus half to the power n upon 1 minus half. This is the sum of n terms. Now here he is asking, so go on adding up to infinite terms. So what's the answer? So the answer to this question is something like, so this limit when n tends to infinity. We have this chapter limit separately, but this formula we have in here in geometry, this sequence chapter only. Now this is just a common sense that, sir, when n will tend to infinity, if you go on adding up to infinite terms, Sn limit when n tends to infinity, this is written as this way. Means what value does Sn approaches when n becomes very large? It should not be 1 crore. N should not be 1 crore. It should be greater than 1 crore. Sir, should it be 100 crores? No, even more than that. Sir, n, whether it should be 1 lakh crores? No, even more greater than that. So don't worry about these notations right now. It is just something that I have written. You can also write S infinity also if you feel comfortable. So this is equal to 2 times. So this 1 minus half as it is. Now what to do of this half raised to n? Can you realize this thing? Can you convince yourself of this point so that as n tends to infinity, a proper fraction raised to infinity, this almost approaches 0. This arrow sign means it becomes very close to 0. Can you convince yourself of this point? Note that it should be a proper fraction. Okay, proper fraction. Proper fraction should be must, means magnitude less than 1. If it's an improper fraction, means magnitude greater than 1, then the whole thing fails. A proper fraction, half multiplied by half is 1/4. It became even smaller. Okay, on the number line, this is my 0, this is my 1. So what is 3/4? 3/4 of a cake, it lies somewhere over here. So 3/4 square. 3/4 square is what? So this distance was 3/4 multiplied by 3/4. 3/4 of this distance. So you have come over here. That is 9/16. So now this distance is 9/16 into 3/4. So you have come over here. Are you getting it? So proper fraction raised to infinity or approaching 0. Is this point clear? Afrin?
Yes, sir.
Okay. So can I write over here now? 1 minus 0 only. So this becomes 2 upon 1 minus half. So that is equals to 2 upon half, which is equals to 4. Okay. So this sum in geometric progression only we should have written. Yes. If magnitude of R is less than 1, the next condition, if magnitude of R is less than 1, this is an important condition, then sum up to infinite terms of a geometric series, you can directly write is equals to A upon 1 minus R. This result also you can write. Okay, let's move ahead now. A particle moves in the XY plane as shown in the figure. The coordinates of the point where the zigzag converges is this is my XY axis, and now the movement of the particle is something this way. Starts from the origin. This is 1. This is half. This is 1/4. This is 1/8. This is 1/16. Coordinates of the point where the zigzag converges with. Dhananjay and Afrin, have you got it?
Yes, sir.
You got the answer, Afrin?
No, sir, I'm trying, sir.
Dhananjay? Okay, see, this is a geometric progression question. We will find out the x coordinates and the y coordinates separately. Can you see for the x coordinates how much distance it is he is moving? Distance along x-axis. So distance along x-axis from the origin. So he has moved so 1 unit to the right. After that, from that point on, along the y-axis, whatever movement you do along the y-axis, that will not have any effect on the x coordinate. So if he is going upwards or downwards, why bother about it if we are calculating the x coordinate? Let it be. If he has moved up, we need not bother. The x coordinate will be +1 plus 1/4. After that, plus 1/16. After that, plus 1/64. After that, so on and so on and so on and so on up to infinite terms. Yes or no? Because Actually, it is a geometric progression with common ratio half, 1, then half, then into half, into half, into half. But for x coordinates, we are taking alternate terms. 1/2 is along the y coordinate, 1/4 is along the x, 1/8 is along the y coordinate, 1/16 is along the x. So 1, 1/4, 1/16, 1/64. This is our geometric progression along the x-axis. So limit the s. This is the total x coordinate. Will be the addition of these two, distance along x-axis. So final x coordinate. Final x coordinate will be what? Final x coordinate will be equal to addition of this sequence. Addition of this sequence of a is 1 minus r to the power infinity, that is 1/4 to the power infinity. We can neglect this thing, upon 1 minus r, 1 minus 1/4. So this is equals to 1 upon 1 minus 1/4 is 3/4, and this turns out to be equal to 4 upon. Got it? X coordinate. Is the explanation clear for x coordinate? Yes or no?
Yes, sir.
Now for y
Yes,
coordinate,
sir.
there is a slight change, only a slight change. Distance along y axis. Distance along y axis. So now from the x axis, along the y axis here, he is going plus half, but then you don't have to calculate the distance as plus 1/8. He's returning back 1/8. So it is positive half, then negative 1/8. After that, what he is doing? He's again changing his direction along the positive x-axis, along the positive y-axis. So the distance along the y-axis traveled is positive half, then negative 1/8, then positive 1/32, then negative, and so on and so on and so on. Now, how to calculate this addition, this sum? So this is again a geometric progression. Don't think that, sir, I will split it in two sequences of alternate terms. No need. This is again a geometric progression. First term is equals to half, and the common ratio is negative 1/4. Do you get it? Common ratio is
Yes,
negative
sir.
1/4. So s infinity of this sequence is first term 1 minus r raised to infinity. R is a proper fraction, so 1 minus r raised to infinity I will neglect it because it is 1 minus 0 only. And denominator it will be 1 minus r. 1 minus r is 1 minus 1/4. So this is half upon 5/4, which turns out to be equal to 2 upon 5. Okay. Is it clear?
Yes, sir.
Yes, sir.
So x and y coordinate will be 4 upon 3 and 2 upon 5. The point where it will converge will be equal to 4 upon 3 and 2 upon 5. If A1, A2 up to AN are in AP, where AI is greater than 0 for all I, show that this symbol is what? For all. Okay, in set theory I have told you the symbol there exists for all. Show that 1 upon under root a1 plus under root a2 addition 1 upon under root a2 plus under root a3 plus 1 upon under root a3 plus under root a4, so on and so on and so on up to 1 upon last is under root an. Okay, and then just the previous is an minus 1 under. This is equals to n minus 1 upon under root a1 plus under root a. Prove. Are you getting, students? Think in terms of rationalization of surds. How you rationalize the surds, that way you should think. Okay, let's see. So first term 1 upon under root a1 you should realize that these are consecutive terms a1 a2 a2 a3 a3 a4. So since they are consecutive terms, that difference is a constant. That difference is a constant. So let me multiply it by under root a1 minus under root a2 first, numerator and denominator both of them. So what it becomes, under root a1 minus under root a2 upon, what will be the denominator? Denominator is of the format p plus q into p minus q. So that is p square minus q square. So whether the denominator will be a1 minus a2, yes or no? So denominator is a1 minus a2. Can I write the denominator to be equal to negative of d? So a1, a2, a3, a4 are in arithmetic progression. So a1 minus a2 is minus of the common difference. Do you agree with me?
Yes, sir.
1 upon under root a2 plus 1 upon under root a3. Repeat the step. This will be what? So a2 under root minus a3 under root upon a2 under root minus a3 under root. So this will be what? Under root second minus under root third upon again negative d. This will be go on repeating everywhere. Last also it will be nn minus 1th under root subtraction nth under root. Lastly it will be, I directly write n minus 1th under root subtraction nth under root upon negative d. Now he is telling you to add all of these things. The LHS, he is telling you to add all of these things. So the LHS that he has asked you, reduces to what? So negative d is the common denominator everywhere. So we just have to add the numerators. The denominators are same everywhere. So just add the numerators. So a1 minus a2. This is a2 minus a3. So then it will be a3 minus a4. So can you see that negative a2, positive a2, negative a3, positive a3, negative a4, positive a4. Telescoping series? Yes or no? So what will survive? Just the first term will survive over here. The first term under root a1 will survive. And here the last term nth under root will survive. Rest all the middle ones, they will get cancelled in pairs. Negative, positive, negative, positive, negative, positive. Is this clear?
Yes, sir.
Now again rationalization. Now again rationalization means what? Multiplied by, so a1 under root plus an under root, a1 under root plus an under root. Correct? So a1 under root plus an under root, what do I get here? So this negative d as it is, and here it is a1 under root plus an under root, and in the numerator it will be sir p minus q, p plus q, whether it will be equal to a1 minus an, yes or no? And here it is negative d. This is a1 under root plus an under root. And now nth term minus first term, the reverse one. Okay, nth minus first term is we are going n steps ahead. Sorry, n minus 1 steps ahead. So this is n minus 1 into d. But the thing that I have written is nth term minus first term. The thing that is required is a1 minus an. So here it will be a minus sign. Is this clear? Nth term minus first term is n minus 1 steps ahead. It is n minus 1d, but it will be with a negative sign. So the final answer is n minus 1 upon under root a1 plus under root a. Hence proof. Okay. Is it clear, everybody?
Yes, sir.
Yes, sir.
So now this chapter theory part is over. On Saturday we will just do one theory, that is of arithmetico-geometric series, and after that this chapter will be completed.